then weight supported by the crane hook. So you can observe in the first image. Okay, so here one object is hanging with the help of two cables. So these two cables, they are connected to the walls, and question will be we have to find out the tension in the cable. Okay, so we can use the conditions of equilibrium, and then we can find out the unknown value, that is a tension. Then second type of problem on the equilibrium, it includes the problem on the sphere. Okay, so you can observe in the second image. So here a sphere is supported by using two inclined walls. Okay, so this inclined wall, they will offer the support reaction at point A and at point B. Okay, so we have to find out the magnitude and the direction of that support reaction at point A and B. So we can use the condition of equilibrium and we can find out the reactions at point A and B. Then third category, it is the problems on the ladder. So in the third image, you can observe the one person is standing on the ladder. Okay, so if this ladder it is in the equilibrium, then 2 points, that is a support point with the wall and support point with the ground, they will offer some reactions. Okay, also they will offer the frictional forces. So by using condition of equilibrium, we can find out those support reactions. And the last category, it is the problems on the beam. So the last image, it is the beam. Okay, so we can use the condition of equilibrium and we can find out the support reaction for different points. So we will cover this problem one by one. So also the second category, it is the equilibrium of the connected bodies. So connected bodies means what? Two or more bodies, they will be connected to each other by using either rope or by using ladder. Okay, so we can use conditions of equilibrium to such systems and we can find out the support reactions for the connected bodies. So this problem, the first category includes two or more objects hanging with the help of a cable. Okay, the second type, two or more spheres, they are connected to each other. Then third is sphere supported using ladder. Then ladder held in the equilibrium using a cable, and beam supported using cable. Okay, so these are the problems or the types for the connected bodies. So first we will solve the problems on the cables. Okay, so this is the first category where we will solve the problems where a weight or object is hanging from the cables. So in the first problem, the length of the rope ABCD, which is connected to the wall or ceiling, okay, it is equal to 4.5 meter. So this total length AC plus CD plus DB, it is equal to 4.5 meter. The point A and B, they are located at distance 4 meter from each other. So this horizontal distance, this is equal to 4 meter. Weight W1, it is equal to 1500 Newton. Then AC, it is equal to 1.5 meter. So this is 1.5 meter. BD is equal to 1 meter. Okay. Then question is, what should be the value of the weight W2? Okay. So that the given equilibrium will be maintained. Okay. So here for the equilibrium, CD is exactly horizontal. Okay. So suppose we want to maintain this horizontal position for the CD. Okay. What should be the value of the weight W2? So for that, we need to draw the free body diagram for point C and D. Okay. So for point C, we will draw the free body diagram. So at point C, there are three forces. The first force is tension in the cable AC. Okay. So this is the tension in the cable AC. Second force will be weight W1. It is in the negative y direction. So this is equal to 1500 Newton. Okay. And the third force, it is the tension in this cable. So this tension value, it is common for point C and it is common for the point D. So this is the tension in the cable CD. Okay. So this is the point C. So this is the concurrent force system. Okay. So for such system, we can use summation Fx and summation F1. No need to use the summation of moment because all the forces or line of action of forces is passing from the same point. So to solve this problem, we must know the angles. That is angle of tension AC with respect to x-axis. Okay. So this angle is not given in the problem. So we can make one construction. From point C, draw the perpendicular on the line AB. Similarly, from point D, draw the perpendicular on the line AB. Okay. So from this, we will get two right angle triangles. So take this point as a M1 and this point is M2. So first triangle will be AM1C and second triangle will be BM2D. Okay. So in this right angle triangle, this hypotenuse is 1.5 meter. Okay. We don't know this value. So let us take this value as a x1 and take this value as a x2. Okay. And assume this perpendicular distance, that is CM1 and DM2, as a y. Okay. Because both the distance are same, because the line CD is exactly horizontal. Okay. So now we can write the equation. Just observe A to B distance. It is given as a 4 meter. Okay. So we can write this distance as, this is x1 or A to B. This is equal to 4 meter. Okay. So we can write x1 plus CD plus x2. So this total distance AB. So it is x1 plus CD plus x2. This is equal to 4 meter. Okay. But CD distance we can find out by using the total length of the rope. So this total length of the rope, it is given as a 4.5 meter. Okay. So total length means what? It is AC plus CD plus DB. So this AB we can also write total length of the rope. This is equal to 4.5 meter. Okay. So total length means what? We have to add the segments AC plus CD plus DB, and this is equal to 4.5 meter. Okay. So AC is given and DB is given. Okay. So unknown value is CD. So you can write here AC is 1.5 plus CD plus DB is 1 meter. So this is equal to 4.5. So we will get CD. So this is equal to, this is 4.5 minus 1.5 minus 1 meter. Okay. So this is 3 minus 1. So this is equal to 2 meter. So this is CD. Okay. So now we can put this value of CD in this equation. So we will get x1 plus x2. It is equal to 4 minus CD. So it is equal to 2 meter. Okay. So this is our first equation. So we have got one relation for x1 and x2. So x1 plus x2, it is equal to 2 meter. Now similarly, we can find out one relation by using this triangle. Okay. So in this triangle, we have got the value for x1 plus x2. And similarly, we will write equation for y. Okay. So we will write from the first triangle. That is AC M1. So from triangle AC M1, we will get 1.5 square is equal to y square plus x1 square. Okay. So from this we will write y square is equal to 1.5 square minus x1 square. Similarly, from the second triangle, that is triangle BM2D, 1 square is equal to y square plus x2 square. Okay. So similarly, y square is equal to 1 square minus x2 square. So this is y square, this is also y square. So we can equate these two values. So from this we will get 1.5 square minus x1 square is equal to 1 square minus x2 square. Okay. So we can write down, if you rearrange the term, it is x1 square minus x2 square is equal to 1.5 square minus 1 square. Okay. So this value will be, if you solve this, 1.5 square minus 1 square. So this is equal to 1.25, and this is equal to x1 square minus x2 square. Okay. So this is your second equation. So if you refer the first equation, we have x1 plus x2 is equal to 2. So first equation is x1 plus x2 is equal to 2. Okay. So this is your first equation. So from the first equation, you can put the value x1 is equal to 2 minus x2, and then put this value in this equation. Okay. So from this, you will get the value as 2 minus x2 bracket square minus x2 square is equal to 1.25. Okay. So you can expand this. So this will be 4 minus x2 square plus 4x2 . So this is equal to, sorry, minus x2 square is equal to 1.25. Okay. Okay. So from this, you can find out the value of x2. Okay. Then put this value in the first equation and then find out the value of x1. Okay. So from this, you will get the value. Just check the answer. You will get x1 as a 1.3125 and x2 value. So this is equal to 0.6875. Okay. So just take this answer. From this equation, we will get the x2 value. Then put this x2 value in the equation 1 or equation 2. Okay, and then get the value of x1. So now you can refer the free body diagram. Okay, so in this free body diagram, this cable AC, we can assume it is inclined at an angle alpha. Okay, so this alpha is nothing but the angle with respect to x-axis. So this is the alpha. But to find out this alpha, we have to calculate the angle A. Okay, angle A in the triangle AM1C. And this A angle is nothing but alpha, because this is alternate angle. So alpha we can find out by using y and x1. Okay, so we can use the tan alpha. So tan alpha, it is equal to, opposite is y and adjacent is the x1. Okay, so this will be alpha is equal to tan inverse y upon x1. Similarly, find out the second angle. So assume the D angle for second free body diagram, it is beta. So this beta is nothing but angle B. So this is also beta. Okay, and this beta we can write down tan beta, it is equal to, opposite side is y and adjacent is x2. So beta is equal to tan inverse y upon x2. Okay, so for that we have to find out this y distance. So you can refer any one formula, y square is equal to 1.5 square minus x1 square. Okay, or y square is equal to 1 square minus x2 square. So from this find out the y distance. So you will get y is equal to, it is 1.5 square minus x1 square is 1.3125 square. Okay, so this is y square. So distance y, it is equal to 0.7261. So by using these values alpha and beta, okay, we can solve the problem and you can get the value of weight W2. So now refer the free body diagram. So at point C, this is the weight W1, that is equal to 1500 Newton. This is the tension in the cable CD, and this is the tension AC. Okay, this angle is alpha. So alpha, this is equal to 28.96. You check this answer by using the tan inverse formula. Okay, so now you can resolve this force, that is a tension AC, and you can use conditions of equilibrium. So similarly, draw the free body diagram for point D. So for point D, this is the unknown weight W2. This is common tension, that is a CD. And this is the cable BD. So this is tension BD. Okay. So first we have to solve this free body diagram and then we can solve the second diagram. Because in the second diagram, there are three unknowns. And for concurrent force system, we only have two conditions for equilibrium. One is summation Fx0 and second is summation Fy0. For parallel force system or for general force system, you can use the summation of moment 0. Okay. So if you refer the second free body diagram, tension CD, tension BD, and weight W2, there are three unknowns. Okay. So we cannot solve directly by using summation Fx and summation Fy. So first, solve the free body diagram for point C. So for the point C, you can resolve the forces. So resolve this tension. So its y component will be tension AC sine 28.96, and x component, it is tension AC cos 28.96. Tension CD is exactly horizontal and W1 is in the negative y direction. Okay. So by solving free body diagram of point C, summation Fx is equal to 0. So for summation Fx, tension CD is positive x direction minus tension AC cos 28.96, it is equal to 0. Okay. And then use summation Fy is equal to 0. So for summation Fy, W1, that is minus 1500 Newton, then plus tension AC sine 28.96, it is equal to 0. Okay. So you can solve this and get the value of tension AC. So the tension AC, this is equal to 3097.9 Newton. Okay, check this answer and then put this value in this equation and get the value of tension CD. So tension CD is equal to 2710.5 Newton. Okay. So once we get the value of tension CD, which is a common value for point C and D, then solve the free body diagram for the point D. Okay. Yes, you can solve this by using Lamè's theorem. So this is tension BD and this is unknown weight W2 and this is common value CD. Okay. So this angle is beta. So you can resolve this. So x component will be tension BD cos beta angle is 46.57. Just check the value. And the y component will be tension BD